All right, Mr. O'Donnell here again, and welcome back to Check This Out Mathematics. And if you like these series of videos, and then please give me a thumbs up and subscribe to my channel, Check This Out Mathematics. And in this series of videos, we have been talking about the Pythagorean theorem, Pythagorean triples, and three formulas that generate Pythagorean triples. And so let's remember what those three formulas that generate Pythagorean triples are. And so here's A, B, and C. That's a Pythagorean triple that is a solution to the Pythagorean theorem. A squared plus B squared equals C squared. And so the first formula that we had worked like this. We had a basis of m, and we could have then say, how does that go? 2m plus 1. I have to go back to my notes here. Oh yes, and then two m plus 2m squared, and then 2m plus 2m squared plus 1. Okay, and so with this basis of m and this formula, we can generate Pythagorean triples, A, B, and C, that fit the Pythagorean theorem, a squared plus b squared equals c squared. And in this arrangement, the c value was 1 more than the b value. And from the previous videos, that one of the Pythagorean triples that we generated was 7, 24, 25, for example. All right. Then we had another formula that generated Pythagorean triples, and that started out with a basis of m and n. And then if we manipulated those numbers to mn, and then m squared minus n squared, and m squared plus n squared, so this was our basis of m and n, and m had to be greater than n in this formula, and this formula here generates Pythagorean triples, A, B, and C, where a squared plus b squared equals c squared. And with that one, see, one of the ones we generated was 8 15, and 17. That formula. Okay. And then we had a third Pythagorean triple generating formula. And this time we had a basis of S and T. And if we multiplied the numbers together and doubled them and added the square of the second value, and if we multiplied the numbers together and added twice the square of the first value, and then if we brought it all together and multiplied the numbers together and doubled it and added the square of the second value and twice the square of the first value, that also generates Pythagorean triples, A, B, and C, where a squared plus b squared equals c squared. And one of the Pythagorean triples that we generated in that example was 33, 56, 65. Okay, so that's what was happening in the previous videos. And now we get to see, we get to check out what's behind me here. And so we've talked about a number of Pythagorean triples. You know, we had 3, 4, 5, and 5, 12, 13. And those were primitive Pythagorean triples. And then we had multiples of those. That's 9, 12, 15. And 10, 24, 26. We had multiples of those Pythagorean triples. And these Pythagorean triples are, the C value is 1 more than the B value. And then we had other Pythagorean triples, 20, 21, 29, or 12, 35, 37. And we used the other formulas to generate these Pythagorean triples. And so now the idea is that we have all these Pythagorean triples, and maybe there's a way to arrange them. And so let's check out what we have behind us here. Okay, so right here we have this we have this 3 squared, 4 squared, 5 squared, 3, 4, 5 triangle. And as you can see, this is 3 squared, that gives us 9, and 4 squared, that gives us 16. And 5 squared gives us 25. And 9 and 16 is 25. So the 3, 4, 5 triangle, and it fits the Pythagorean theorem. It's a nice illustration. And maybe we want to have a way to have all these Pythagorean triples. And so maybe we can start here with this 3, 4, 5 triangle. This 3, 4, 5 Pythagorean triple. And then maybe and remember this is a primitive Pythagorean triple, 3, 4, 5. And maybe if we go to this one, we have the 5, 12, 13 Pythagorean triple, another primitive triple. And so now we're looking for number 3. Here we go. Right here, we have 7, 24, 25. 7, 24, 25. And so all primitive Pythagorean triples there. And maybe we can look for the 4th one. Here we go. This was, these were all the ones that were where the C value was 1 more than the B value. So this is the 9, 40, 41 Pythagorean triple. And let's see, 5. Another Pythagorean triple where the values are 1 apart. 11, 60, 61. Here it is. Okay. And here it is. Another Pythagorean triple where the C value is 1 more than the B value, 13, 84, 85. Okay. Nice little arrangement of the Pythagorean triples coming together. Number 7 over here. We're looking for the ones where the B value and the C value are 1 apart. That was all of them, right? Oh no. That's number 7. But let's jump to this one. We have another Pythagorean triple, 8, 15, 17, another primitive Pythagorean triple. And number 8, let's look at this one. This is 12, 35, 37. That's another one that we saw earlier. And then let's see, behind door number 9 is 16, 63, 65, another Pythagorean primitive triple. Okay, and so then that's number 10 now. Where's number 10? Oh yes, here's another primitive Pythagorean triple, 20, 21, 29. Okay, so that was we're looking for number 11 now. Here it is. Okay, behind door number 11 we have 28, 45, 53, another primitive Pythagorean triple. And And let's keep revealing these here. Here's number 12. This was our palindromic Pythagorean triple, 33, 56, 65. And then below that, we have 36, 77, 85, another Pythagorean triple. And then over here on this side, we have 39, 80, 89, another Pythagorean triple. And then below that, we have this one, 48, 55, 73. And one more in this group here, 65, 72, 97. And so in this, all of these red Pythagorean triples here, these are all primitive Pythagorean triples. And what we're trying to do here in this arrangement is keep all the numbers under 100. And so all of these, if we do the multiples of these, will be over 100. So that's one block here of all primitive Pythagorean triples, where each of the values are 1 or 2 digits, and keeping everything under 100. And so now then, number 17. Let's talk about some, let's look at some more Pythagorean triples. Oh, here we go. Okay, here we had 9, 40, 41. And so now we're going to get into the multiples of these Pythagorean triples. And if we look at this one here, double it, we have 18, 80, 82. And if we take a look at this one, 12, 35, 37, and we double it, we have 24, 70, 74. Another Pythagorean triple that's a multiple of this primitive. And so let's see, now we're looking for, let's go to this 7, 24, 25 triple. And we have 14, 48, 50. And then we have 21, 72, 75. And so here we had some, we had primitive Pythagorean triples, and we didn't present the multiples of those because then we would be over the limit of 100 that we wanted to have kept here. And then we presented 2 Pythagorean triples, and they each have 1 multiple, keeping it under 100. And then here's a Pythagorean triple with 3 multiples that keep it under 100. And then for 20, 21, 29, we can find another 2 multiples of that, 40, 42, 58. And then 60, 63, 87. So those, here we have a set of 3 Pythagorean triples. And now, here we have 8, 15, 70. So let's see how many triples we have here that are multiples. We have 16, 30, 34. And this one, that's 24, 45, and gotta adjust the camera a bit. There we go. 24, 45, and 51. Okay, so 8, 15, 17 times 2 times 3, and 8 times 4 will be 32. So here's another multiple of that, 32, 60, 68. And another multiple of that times 5, 40, 75, 85. All right, so that completes our 3 by 3 here. And let's see, now we have this 5, 12, 13, and we can look at the multiples of those. 10, 24, 26, and 15, 36, 39, and times 4 gives us 20, 48, 52. And times 5 gives us 25, 60, 65. Are you liking this? Pretty interesting here. And then we have 30, 72, 78. That's 5 times 6, and 12 times 6, and 13 times 6. And 35, 84, 91. And now we're getting to our hundreds. We stop there. And so this is 5. This is the 5, 12, 13. And this is the times 7 multiple. All right. Now we only have one more family to go through. And so we have 3, 4, 5. And if we look at the next one, 6, 8, 10, and 9, 12, 15. And look at the next two. 12, 16, 20, and 15, 20, 25. And if we start here at the top again, that's times 6, 18, 24, 30. And times 7, 21, 28, 35. And times 8, 24, 32, 40. It's all going to work out. Pretty cool stuff. Glad you could tune in and check this out. 27, 36, 45. That's the times 9 multiple. And times 10, 30, 40, 50. And then starting back at the top here again, times 11, 33, 44, 55. And 36, 48, 60. That's times 12. And times 13, 39, 52, 65. And times 14. 3 times 14 is 42, and 56 and 70. And then we have 45, 60, 65. That's a times 15 multiple. And then times the 16 multiple, 48, 64, 80. And then 51, 68, 85. That's our times 17 multiple. And our times 18 multiple, 54, 72, 90. And our 50th Pythagorean triple in this arrangement, that's 3 times 16, 17, 18, 19. Yep, 3 times 19, 57, 76, 95. And so now here we have a nice arrangement of the 3, 4, 5 triangle and all the Pythagorean triples, where the A, B, and C values are 1 or 2 digits, keeping everything under 100. All right, check it out. It's pretty cool. All right, thanks for tuning in to these series of videos on Check This Out Mathematics. And please give me a thumbs up on this video, this series of videos, and like this channel and subscribe to it, and put some comments down below. What do you think about this? And I plan on doing a couple more videos about this series, sort of a prequel. And we're going to add some more content to this channel. We're going to talk about weird numbers and untouchable numbers and amicable numbers, and then we'll talk about this talk about all sorts of interesting things that I happen to like, and maybe you'll like them too. All right, thank you very much, Mr. Donald. I'll see you again.